Alright, so apparently one of my students, he came around and he was like, "Oh, all of you teachers can't actually do contest math. You are so bad at this." And he brought me the AMC12 booklet, and I was like, "How did he get it?" And he said his testing center didn't care, so he made a digital version for me, and I have to prove that us as math teachers, we're also great problem solvers. Now, keep in mind, my solution is most definitely not the greatest because I haven't actually done contest math in so long. Not the greatest shape right now. All right, let's start with problem one. Problem one is really simple. So basically, you have 350-gram bag of coffee bean that says the proper brewing of a large mug of coffee requires 20 grams. So how many number of properly brewed large mugs of coffee can be made? So basically, this is 350 over 20. And if you compute that, if whether you actually divide it out or you just, do some mental math, you'll get 17.5. Now, since we can't round up because we can't brew 18 pots, clearly the highest we can brew is 17, which gives us the answer of B. Second question is actually a pattern question, which I think is kind of it's a little rare because I did not. There's another pattern question over here that I don't think there's a lot of pattern question on the A one or the last year one. So if you wrote down of all the first few positive squares, which actually I would write it for you. So to start off, or by the way, we're looking at the ones digit. So before one, there's actually zero, 1, 4, 9. A lot of people missed 0, which is, I think, a huge problem. 16, 1, 2, 3, 4, 5. I'll write this here. 25, 36, 9, and our 9 times 9, 81. And then we loop around 100 again. So if you look at this, and your next one is 101, 121, by the way, and then it's 144, and then you realize, okay, so our pattern right here is this: 0, 1, 4, 9, 6, 5, 6, 9, 4, and then look, it's 1 again. So it repeats on itself. So these are basically what we have noticed. Now we notice that this pattern repeats every 10 numbers. And so let's figure out the sum of this, because we need to figure out the sum. Right? We want to figure out the sum of the numbers that he wrote down, that Jerry wrote down. Yeah. So let's add all of this together. So I have this in front of me. If you don't, just follow along. Just make sure I'm writing the right numbers. We had 1, 4, 9, and we had 6 from 16, 5 from 25, 7 times, sorry, no, it's 6, sorry, 636. And then we had 49 from 7 times 7, plus 64 from 8 times 8, and 1 again from 9 times 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. Compute the sum, you will get 45. Right? So now what we need to figure out is we have 2025 positive squares. We have to figure out how many times this actually loops. So 2025 divided by 10, 10. We're gonna go ahead and get pretty straightforward because it really doesn't require that much math. Come on, like this is a no calculator test for a reason. So we have a 5 remainder, so 202, and we looped how many times? We looped we looped 202 times. We multiply the sum of each time of 45, and that you actually have to list it out, or you could just do this times that, this times this, and you will get 90 times 90. Sorry, 9090, right? 9090, and then remember you have a remainder right here. So 9090, you're going to actually add the first 5. Oh, I should have erased it. Oh, god damn it. Jeez. So you actually have to add 1, 4, 9, 6, and 5. This adds up to 25, right? And then 9090 plus 25 is going to go ahead and get you 9115, giving us the answer choice of D. Third one, complex root. It's really how you group it. So I've seen three different ways. This kid wasn't mathematical genius. He came up to me. He came up to me pretty geniusly. And he came up to me. He grouped it differently than I did, which I guess it works. So I grouped the first two together, which is the I and I minus 1. You will go ahead and get I squared minus I, which obviously simplifying, you could go ahead and get negative 1 minus I. Then I grouped the second one together, which you would do, FOIL. Um, I forgot what it actually stood for. Doesn't matter. It's I squared. You will go ahead and get I squared minus 5I plus 6. And now this can be simplified to negative. This is a negative 1, by the way. So negative 5I plus 5. Right? Yes, it is. Oh, this looks like a 9 minus. My bad. So now we have this and this, and let's go ahead and multiply together. So negative 1 minus I multiplied by negative 5I plus 5. And you do this expanding again, or you could factor this out, the 5, and you will get negative 5 of negative I plus 1. And oh, you could, sorry, you will get plus, sorry, I minus 5 and 1 minus I. What am I doing? 1 minus I and 1 plus I. Okay, good. And this we can expand it again. So 1 plus I minus I and minus I squared. So 1 minus negative 1 is actually plus 1. So sorry, what? 1 minus, so plus 1. Yeah, so it's 2. This is 2 here. And negative 5 multiplied by 2, you will go ahead and get negative 10. And that will be your answer, which is D. Okay, two-digit number AB base 7 is equal to the value of two-digit number BA in base 9. So how would we figure this out? So simple way to rewrite it. A is in the tens digit. So when you look at something like this, you put A here and B here, right? Tens and ones. So instead of AB, we could go ahead and write it 7A plus B because it's base 7, right? I've seen something similar on the COMC this year, which is pretty interesting because as a Canadian person, I usually like the COMC better. But it's always math. All right, 9B minus A. So we could go ahead and set this equal to each other, and you'll realize that you're gonna get a ratio. Well, not really well, I guess a ratio. So when you set this equal to each other, you're gonna go ahead and get to 6A is equal to 6A is equal to 8B. Or otherwise, you could say reduce this and 3O equal to 4. So now this is really a guessing question at this point. So it's not really a guessing question, to be honest. I think it's pretty straightforward. I don't know if anybody else thought it was pretty straightforward. But it's clearly this is 4 and this is 3, right? This is the lowest common factor lowest common multiple that we could get. So obviously when we have this A equals to 4 and B equals to 3, you add them together and that is 7, which is option A. Now, go on to number 5. So number 5 is really, I guess, a trial and error, but there are some techniques to it. 57x plus 22y is equal to 400. So first we could try small values of x because we can't try too big. whenever we try too big, not good. So, and we also have to make sure a huge thing is that y is actually an integer. So when you try 1, you'll realize that you're gonna get 57 plus 4. Sorry, 57 plus 400 divided by 22. And then 400 minus 57, you're going to get 343 divided by 22. And you know it's most definitely not divisible because there's no way you're going to multiply 2 to get 3. So we know that's not divisible. So let's go ahead and try 2. So when you have 57 times 2, you're going to go ahead and get 114. And that is equal to the 400 minus 114, 286. So 22y is equal to 286. So you look at 22 and you're like, is this divisible? 286? Yes, I believe so. Right? Also remember that out of these combinations, it is very unlikely that you're gonna get multiple combinations that satisfy this. So whenever you get a combination, I think you should stay with it. So I checked everything else. But I realized I was right. So x is equal to 2 and y equals 13. So when you do this divided by 286 divided by 22, y is going to get 13. So 2 plus 13, 15, and you're going to go ahead and select E. All right. Now let's go ahead and do 6. So 6 is really interesting. It depends on how you really look at it. I didn't look at it. I didn't look at it the smart way at first. I looked at it the dumb way. But I realized it doesn't really matter. So we could go ahead and look at this because there's so much interpretation of that was a good price. I mean, there's a lot of interpretations of it. So I could write all of this in cent. So I'll have the decimal on the very right, and I will have a wow. I would have a b b b a dot 0. In which case I will have 10,000 a. So this is a great way to actually break it down, which I like to do. Plus 11,000 b. Well, you could just do 1110b plus, and you're gonna get this at that. So 1001a plus 001a. So since this 36 was bought, so this is 36. So for this, so when I interpret it, I assume that this has to be an integer, right? I guess that was a good price. So I checked the divisibility of 4 and 9 because right, it's divided by 36. So if I check the divisibility by 4 and 9, it's gonna help. So I realized, okay, did it help? Yes, of course it does. So whenever we have 1001 da 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 mod 4 da 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 da, so a plus 2b. So whenever you do mod is this, you're basically looking for the remainder, right? We can now try value. So a lot of this is trial and error, but you also have to know what you're trying and what you're erroring. So for me, I guessed a to be 6 and b to be 5 because I want to get the remainder to be 0. So you could always do estimations. Since you're not allowed in calculator, just do hand estimation. It always work. Try your best. So you want something that's divisible by 36. So basically divisible by 4 and divisible by 9. So when I have this, I simplified this equation to to a plus 2b because we modded it. So a plus 2b, and we want to make the denominator, the remainder of this. Whenever we divide it by 4 divided by 9, we want to make it 0. So when we have this. And for mod 9, we will have 2a plus 3b. Whenever we have this, we can go ahead and plug it in. So 6 plus 10, 16 divided by 4, sure is divisible. Perfectly divisible. This 2, 6, 12 plus 15, 27 divided by 9, it's also divisible. So I proved that my value was right, and C is the answer of B and 11. So a lot of this is trial and error up until this point, and you see that I'm making educated guess. Yeah, it is what it is. Alright. Problem 7 really wasn't spicy. It was pretty light. It's how you simplify it. Right? So I'll go ahead and simplify the top first. So, sorry. What? Yeah, I'll go ahead and simplify the top first. So I could notice that 1 plus 1 over n. I could actually rewrite this as n over n plus 1 over n, giving me n plus 1 over n. Right? Because there's an n plus 1 at the bottom. And I really want that n plus 1, right? Whenever you look at something at the denominator and you're like, okay, I want to make the numerator the same, right? I'd really appreciate if it was there. So you got to establish some mathematical creativity. So due to the log rules, we're actually able to separate this into log of n plus 1 minus log n. Because it was the quotient, quotient law. Quotient rule? Quotient law, yeah. Quotient rule is the calculus thing. Derivative. Yep. It doesn't matter the base. They have two here. It doesn't really matter as they are consistent. But you do have to plug in later, so it doesn't matter a little bit. So now the top becomes this, and the bottom is, we didn't simplify at all. The bottom is log and log to log to the n plus 1 base 2. And so you look at it, and you're like, what can I do here? What can I do? I could simplify it for sure. So what if I flip it? What if I flip it to become this? 1 over log 2n minus 1 over log squared log n plus 1 to the base 2. Keep on saying it's squared. When it's really not. Right? We could flip this. This is fully legal. Right? Whenever we flip this, this is fully legal. So now we could go ahead and sum it. So there's a way to sum it, right? Obviously this is if you actually try it. So this is when you plug it in, n equals 1, and this is 2. So it's always going to be 1 minus 2, 2 minus 3. Sorry, you're starting at 2, right? Yeah, you're starting at 2. So 2 minus 3 log 2 to the base 2 minus 3 log 3 to the 2 to the base 3 to the base 2 minus 4 to the 3 and so on and so on so on until you hit. So I'll write it out just so you guys can see it, visualize it a little bit better. A lot of you are visual learners. So you're gonna go ahead. The sum of the, oh my god, the sum is 1 over log 2 to the base 2 minus log 1 over log 3 to the base 2. Then I group this. Then plus 1 over log 3 to the base 2, 3, minus 1 over log 4 to the base 2. And da 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 blah 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 all the way until 1 over log 255. Yeah, 255 to the base 2 minus 256, right? You get the point. So now we realize that all of the intermediate terms, they will cancel out. Right? This is a power of logs. The intermediate terms, they cancel out. So what happens is that after we figure out the brackets, we have a negative, positive, a negative, positive, a negative, positive. Because look, 2 and 3, you could just forfeit the log right now. And then you're going to have plus 3 minus 4 plus 4 minus 5 plus 5 minus and blah, 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 all the way onto 256. So you're going to left with actually only 2 values. And that being 1 over log 2 to the base 2, which is your first value. Actually, you don't have anything to cancel it out because that's where you started. This is 1, by the way. So 1 over 1, 1, right? This is 1. And you will have your last term that you didn't cancel out because you don't have anything that comes after it. So 2 to the 256. So 2 is like one of the basic ones that I think everybody should remember. Not sure if everybody does, but I remember 2 to the fifth power is 32, and we know 6 is 64. Then it's 128, and then it's 256. So wait, we just did 3, right? We just did 3. So that was what is it? 2 to the 8, right? So it's 1 minus 1 over the 8, right? All of the bottom is 8. So it's 1 minus 1 over 8, and you're gonna go ahead and get 7 over 8, and that is gonna be C. And let's go ahead and do polynomial polynomial x cubed minus 5x squared plus ax plus b has the root 4 plus root 5 as a root. What is a plus b? Okay, this is a decently interesting question. Yeah, I am a little rusty at this. Okay, 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 okay. Since we know that all of the coefficients are integers, that means that the conjugate of 4 plus root 5 is also a root, right? So we have 2 roots now actually, because you really can't do this with 1 root. You have to. Does this specify? Yeah, they specify all of the integer. Okay, so that's good. We don't have to assume. We are using a math law here. So could go ahead and let the third root be u. Formula out there called the Vieta's formula, Vieta, Veta's formula, or I don't know. I don't know what this guy called. He was ah, dude, I couldn't remember. This guy he was a great mathematician, but oh Jesus Christ, I don't remember. So he taught the sum of roots formula, which was negative b over a, and the product roots formula, and for a cubic function, he gave us all the roots, right? For a cubic function, we could have all the roots r1, r2 plus r3. This is gonna give us negative b over a, but it's only in a polynomial equation of ax da 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 da. So we're gonna use I guess a variation of his formula. So we're gonna still use the formula for roots. 4 plus root 5 plus 4 minus root 5. So there's supposed to be a bracket, but I kicked it off because it doesn't really matter to a negative. It doesn't even matter here actually. And what did we say? We said our third root was u, right? So u. Let's actually add this up. So 8 da da da. So you got 8, and we know our sum of root is da 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 b over a, right? So b over a in ax cubed plus bx da 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 da. So our hold on, where's our b here is negative 5 or 5 for the exact value. So 5 over 1. So we have 8 plus u is equal to 5. So ux equal to 3. So congratulations. No, it's not. It's negative 3. Oh my god, what am I doing? I just doubt myself now. Holy crap. Alright, so u is negative 3. So we figured out all the roots for now. Well, not for now. This is yeah, cubic function. Only 3 roots. Good. So go to do the product of these rules. equals root. So we multiply this together. Note that these are conjugates, so it's a difference of squares. So it's 16 minus 5. So 11 multiplied by negative 3, so negative 33. So times all of this is equal to negative 33. But hey, you're like, wait a minute, wait a minute. So how does this even help, right? How does this even help? Well, what is the product of roots equal to, guys? Well, the product of roots in a cubic function, it's actually equal to the array, and d in our case, which is actually b right here. It was okay. The general formula for Vieta's formula is ax3 plus bx squared plus cx, following alphabetical order. But in here they messed it up. So whenever we do this, do a product of roots, it would be equal to negative d over a. I believe they taught this in enriched functions. Yeah, I keep on doing it in enriched functions. I know a lot of people that does it in enriched functions. Of AP, gifted, if you take any of them, they will teach these formulas. So our a is still 1 here. So our negative d. So negative 33 is equal to negative d. So that means d equals 33. So we figured out the value for b here. Good, good. At least we figured something else. At least we figured something out. So now how do we figure out a? So we remembered there was actually one more formula that was so strong for this. It was R1, R2 plus R1, R3 plus R2, R3 is equal to CRA. Boom. That is our last formula. And because A is 1 in our case, boom. We just got it. So R1, R2, we already got that. 60 minus 5. What is it? 11? Yeah. We had 11. Now, the rest it gets a little complicated. You would have another negative 12 minus 3 root 5 plus 4 minus negative 5, negative 3. So that should simplify down to 11 minus 3 times 8. So 11 minus 24. Right? You guys can plug this in. This is your root 1, root 2, root 3. I'm just doing this in my head. You guys can plug this in to see if I'm right or not. That will give you negative 13. And negative 13 plus b, which was, sorry, this is plus. You're going to go ahead and get 20. And there you go. That's your answer C. So, personally for me, a lot of these questions are a little challenging, but not really. I just need to figure out the formula and all of that. Yeah, so all we had to do is use one Vieta's formula. And another thing is, when you're doing these contests, I think tab management is a huge thing. I keep on telling everybody because once I took the Euclid contest with my kids, my students. They were so happy to see me there to problem solve and enjoy the mathematical spirit with them. They were so happy to see me there, and I was like, yeah, Euclid is one of these contests that I recommend to everyone because it's friendly. I think everybody could give it a little shot. Everybody could give it a little shot and get a little decency out of it. But anyways, let's go ahead and tackle this. I will leave because I do want to leave these questions next time. And 12, I also want to leave 12 because 12 I never really found a way to solve it without calculus. I know. I know. This kid laughed at me today and he was like, "Oh, you can't find it without calculus? Ah, loser." Whatever, whatever. Whatever. Anyways, so this is actually another cycle problem, by the way, if you didn't notice. So let's look at the last two digits of the power of 6. 36. 2 and 6 would be 16. 96. And 76. 56. Right, you actually have to multiply this out. I already did that. And I used the calculator. I'm sorry. So you realize that this is a whole big loop. So 60 to 6. we can actually figure that out. I use the calculator. You guys shouldn't. But your calculator actually it displays it in a scientific notation, so you can't know the answer right away. Anyways, so we look at this, and we're like, okay, so this just loops again, because 6 to the 6 to the 6 to the whatever power, they're just 6. It doesn't matter. What's the 10th digit? 5. Right away, crack the answer. So because I actually took this test, I keep on giving my kids so much homework. They hate me, and they want to. They have been waiting for a chance to give me some homework back. They gave me this homework, and they were like, "Oh, let's see if you're actually qualified to teach us." So I actually took this, and I was really down on myself at this point because I had one C, another C here, another C here. I had 4 C's in a row, and I'm like, huh, little fish, Teachers doubt themselves too, even though I love giving you guys this. Anyways, so the altitude to the hypotenuse 30 minus 30, 60, 90 right triangle is divided into two segments of length. The altitude, by the hypotenuse, by the way, x such that x is smaller than y, but the median to the shortest side of the triangle. Wow. So you look at this and you're like, what? What? I don't get this. Yeah, me too. I when I first read it, I didn't get it, but it's okay. Whenever you have a triangle thing, the first thing I will. Oh my god, I cannot draw a straight line. First thing I would recommend you to do is always draw out your little triangle. Note it's a special triangle, which is a little special when I saw it. So I guess you could do what, ABC? Sorry, ABC, and let's wow, hey, DC, not intended. Or we could do, I don't know, CAB, sure. So we know this is root 3, right? Because this is coincidentally, or not, maybe not coincidentally, our special triangle. And let's put C. Let's say this is vector, because I like doing vector math. 0, 0, and oh my god, and our B here is 0, 1. Or I guess you could say 1, and this is 1 root 3. Okay, good. So the altitude from C to the hypotenuse. Sorry, what? The altitude from the hypotenuse to the hypotenuse. Sorry, I placed my coordinates wrong. I did when I did it on paper. I probably did this differently. But is this what I placed it? I guess so. All right. So from C to the hypotenuse, AB. This will intersect at a random point, somewhere on the hypotenuse. I don't know where it is. Somewhere on there. So the midpoint from A to the midpoint of BC intersects this altitude. Intersects this line at somewhere, let's say P. Now we can actually recommend. Oh my god. We can actually represent all of this out because this is a special formula, and because we are placing it in a plane that we would like, we can actually set whatever point this is. So let's go to this point D. We actually know this point D, and instead of writing A here, let's write A. Sorry, instead of writing 1, let's write A here. So now this would be A root 3 over 4 and 3A over 4, because we're writing it in terms of A, right? Now P, this point, you will get A root 3 over 7 and 3A over 7, because we're being asked the medium, right? So with the altitude of CD is divided into CD is divided into these parts, into DP and CP and PD. So the lengths are proportional to 4 over 7 and 3 over 7 of CD. So we look at it since X is smaller than Y, and PD is 3/7 of CD. And CP is Jesus, my throat really hurts. 4 over 7 of CD. You would divide this and go ahead and divide everything out. You're gonna go ahead and get 3 over 7, which is what I got. I believe I drew this diagram a little more stupidly because I didn't understand the question at first. But yeah, this one should be 3 over 7, which is A. 9 athletes, no two of whom are on the same height, and trial for the basketball team. One time they draw a wristband at random without replacement from a bag containing 3 blue, 3 red, 3 green. They're divided into blue, red, green. The tallest number of each member is named the group captain. So what is the property of the other group captains? Are the actual three tallest athletes out of the entire 9. So matrices problem, I like this. The total number of way to actually assign color. So I'm going to be 9-3 matrix 6-3. Figure that out, calculate it. I got 1680. I do plan on teaching matrices, but not for now. So the number of ways to assign the color to the 3 tallest one, it's 3 factorial. It's gonna go ahead and give you 3 times 2, which is 6. Um, the remaining 6 athletes are assigned remaining colors in 6-2, 6-2, 4-2. Know that there's brackets here, and that is actually 90. Thus, we can conclude something. The number of favorable outcomes where we have the 3 tallest athletes, the tallest athletes in each group is actually the tallest athletes out of everyone. It would be 6, which is how many ways to the number of ways to assign colors to the 3 tallest, times the way to do this, the way to make sure that we assign the rest of the people in 90 ways. So that is actually 540. And now we remember we at the start we did 9-3 and 6-3. We did the matrix and we got 1680. So we have to do this divided by the total possible ways, 540 over 1680. So right away take away the 0, 54. What can we divide it by? So we look at it. Once there, let's go ahead and divide it by 6. Sure. So we're gonna go ahead and get a 4, 9, 6, and this is 68, 11. No, what am I doing? What am I doing? 2 and 20. No, 2 and 48. So 20. 28. Yeah, 2 and 8. So this will go ahead and give you C. So another C in the bag. Not really good. And I'm gonna skip 12 because I only did that with calculus, and I don't want to do it with calculus. Honestly, I think it's pretty stupid. I really don't want to do it with calculus. Yeah, no, I don't want to do it with calculus. So yeah, let's actually go ahead and do 13. Now I'll do a few more because it's almost an hour, and I actually spent more time talking about it than I actually did it. Yeah. Anyways, so let's go ahead and label the sectors first. So we're having a circle that's divided into 6 sectors of 6 different sizes. Doesn't matter if the size actually here. They're trying to trick you off. So let's go ahead and do this. Label it 1, 2, 3, 4, 5, 6. Right? And we can assign numbers from red, green, or blue. Hey, RGB, it's RGB lights. Look, so fun. Yeah. Anyways, each color is used exactly twice, and we can't have 2 neighboring colors be painted the same. Okay. So let's first count the valid color range. So on a 6 cycle, the number of independent sides of size 2 is 6-2. Matrix, by the way. But you have to minus 6 because we can't have neighboring. So 15 minus 6, 9. right? Now, let's go ahead and look at this. Let's count this. This is for red, by the way. So let's go ahead and count the possible ones for green and blue. So I did this the function notation way, as a math teacher would usually do. Hey, turn everything into a functions problem because that's math. That's what math is all about. Let f of r be the number of ways to color the remaining 4 sectors with green and blue, such that no adjacent sectors share the same color. So case 1 is red sectors are at 1 and 3, or 2 and 4, or 3 and 5, or 4 and 6. So they're 2 apart. So the remaining sectors will form an isolated vertex and a patch of 3 vertices. So on a path of 3 vertices, there are 2 valid coloring patterns, obviously being G, B, green, blue, green, or blue, green, blue. Not much here. And this kind of remind me of biology where they had the codons, yeah. so so we only have two ways. 2 ways for this case. So what about red sectors at when they're three numbers apart? So we have to write a 2, by the way. So they're either at 1 4 or a 2 5 or a 3 6. So then on the edge we'll be able to have 2 valid colorings of green, blue, and blue, green. That's just alternating, right? That is total coloring for 2 edges. Now total we have 4. And by the way, we can switch this around. So green, blue, blue, green, and then green, blue, blue, green, green, blue, blue, green, since they're always selective. So we could go ahead and have 4 ways here. Now let's compute the total possible colorings. So at the start we had 6. Right, on the 6th cycle, yeah. On a distance 2, there's when red is 2 apart, we have 6 of these possible choices. And we multiply this by 2. Because there's two types, sorry. What am I saying? There's 2 possible times when they have 6 choices, plus 3 times 4, which is what we had later. That will give us 12 plus 12, which give us 24. That is D. So it's good to stay away from C a little bit. So now let's considering this continuously decreasing sequence of n with positive integers x1 is smaller than x2, is smaller than x2, is smaller than xn, that satisfy the following condition. The average of the first 3 terms in the sequence is 2025. The for all 4 is smaller or equal to k is smaller than or equal to n. The average of the first k terms in the sequence is 1 less than the average of the first k minus 1 terms in the sequence. Blah 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 blah. What is the greatest value of n? So yeah, it's a little stupid to understand, but let's write this out, shall we? So sk second one, by the way, second one over k is equal to sk minus 1 over k minus 1 minus 1. All right, let's actually write this out because this is some mathematical representation. Average of the first k terms in the sequence is less 1 less than the average of the first k minus 1 terms in the sequence. Okay, sure. We're using s as in sum, where sk represents this entire series. X1 plus x2 da 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 da. So since the first 3 terms, their average has to be 2025. We can also know that we can note that x1 plus x2 plus x3 is 6075. 2025 multiplied by 3. So let's go ahead and find a formula for xk when k is greater than 4, greater or equal to 4. So instead of this, let this equal to, let's say, u. I love you. Oh guys, I love you. Yeah. So when and u is the average, by the way, because this is average. This is average, guys. Not sure if you see it. Sum minus the number of terms. That's average. All right. So the average at 3, it's obviously 125. That was given. So okay, A of k, so U of k, we could rewrite this as 2025 minus k minus 3, right? Because we minus out the three terms already, right? You can't. That's not. That, hey, I'm just rearranging it. You can't say that's illegal. I'm just rearranging it, right? So now after I rearrange it, I'll get 2020. Oh my god. So I will get UK at any k that's above or equal to 4 is equal to 2028 minus k. And now I could go ahead and remember I could plug it in back because we let UK is equal to k sk over k, right? We can now actually figure this out. So s of k, s sum of k is equal to k of 2028k k minus k squared. Also, since the sum of k is equal to s, oh my god, since s of k is equal to sk minus 1 plus xk1. Oh my god, sk minus 1 plus x1, right? We're just making it back, right? This is fully equal. We can actually write this out as an equivalent formula. At xk, we can figure out xk, by the way. This would equal to, remember, s of k, s sum of k is equal to sum k minus 1, so that would have been k 2028 minus k and minus k minus 1. I remember what we have of 2029 minus k, right? So simplifying, we have 2029 minus 2k. So for k greater than 4, we will have xk is equal to 2029 minus 2k. So this is something incredible, honestly. We just bounded it. Well, we didn't bound it, but at least we figured it out. We can figure out xk, right? Good. So now let's determine the maximum n, assuming that it's all positive. So we require x of n to be most definitely bigger than 0. Now, let's say instead of k now, we're doing x of n is equal to 2029 minus 2n. Right? Remember that this is also it's a justifiable function notation, right? Whenever I write s of subscript k, I'm actually telling you that, hey, look, it's a function notation. So 2020, so x of n is equal to 2029 minus 2n. And we can actually go ahead and simplify this blah 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 blah, since n has to be an integer, which it says here, right? So all of these are integers. All of these are integers. So minus 2n, 2n, 2029 divided by n. It's gonna give you what n is smaller or equal to, no, this is a strict one. Actually, no, it's not. This is non-strict. 1014, and it should be 0.5, but because it can't be. It has to be an integer. So there we go. Now we could go ahead and check it and make sure that we actually got it right. But since I'm not that type of person to check my answer, you guys could check this. You could plug it back in and see if you guys have this and if it satisfies everything. So you could go ahead and get B for this. B. So yeah, that is as much as I want to solve today. I do plan on solving more of these. Though they're a little hard, I think most of these are articulatable. Yeah, I could see this. This is pretty easy. I did something like this. I put one of these on the test before. Yeah, this was one of this. This was pretty interesting. And yeah, this is.